Hi everyone. In this video, we are going to look into what are the different types of data that we produce at Outlier. So let's look into the first one. So the first type of data that we produce is called supervised fine tuning or SFTs. Now this might sound like a really complex, super technical term, but in reality, it is really easy to understand. So in this type of data, what you do is that you provide a prompt to the model that is challenging for the model. You write the perfect response, becoming the AI yourself. So you pretend to be an AI and you write the perfect response to that type of prompt. Now, all of this data is then sent to the model for fine tuning. And the model picks out certain patterns from that data to sort of improve upon its capabilities and then produce similar responses based on similar questions. So just to summarize, you provide the model a particular prompt, you provide what the perfect answer should have been, and the model then learns from this data to become more capable. Next up, let's look into the next type of data that we have that is called as RLHF or reinforcement learning from human feedback. Now, in this type of data, this again sounds really technical and really complicated. But here what you do basically is that you provide a question to the model and let the model respond with whatever it is already trained upon. So now you as a human, you judge the response of the model. You see if it is incorrect. You provide a certain feedbacks to the model. So you tell the model that, hey, this is where you went wrong. This is what you should have produced. So you also provide the model what the correct response should have been. When you do that, the model then tends to remember from this information and sort of fine tunes itself so that it does not make the same mistake again. So this is called as RLHF. There is this data set that Anthropic has also produced for their RLHF data, which you can scan this QR code and you can explore. And I also leave the link for this in the text above this video. So now let's look into the third type of data that we produce, which is called as evaluation sets. Now, this is really interesting. Have you ever wondered that anytime any company creates a new model, they come out with certain scores that, hey, our model is this much better than this model. How do these companies come up with those scores? They're all because of these evaluation sets. Just like a typical machine learning flow, not all of the data is used to train the model. We use typically 70 to 80% of the data for training, and we keep the rest of the data to test the model so that to evaluate how the model performs based on data that it hasn't seen before. We use the evaluation sets that we create in order to identify which model is actually better at which type of task. So you can go to scale.com/leaderboard and sort of explore around with all of these different use cases and different types of evaluation data that we have. The next thing that we need to clarify is what is the core difference between an SFT and an RLHF? So think of this, like if you are studying for a competitive examination, when you go through all of the data in the book and you sort of read a lot of question answer pairs, that is SFT. Now, when you sit down with your friend who's also preparing for the same competitive examination, and your friend asks you a particular question, and if you do not respond correctly, your friend tells you what the correct answer is. So in this way, humans tend to remember a lot better when you are sort of quizzed on a particular topic. Similarly, the models also have this tendency where this RLHF actually trains these models better than SFTs. So this is the difference between RLHF and SFT. In SFT, you are reading through just a bunch of data that you have. And in RLHF, someone is actively questioning you and correcting you wherever you're going. So next up, let us look at what is the impact of your work at Outlier. So you might have this question, and I have asked this question a lot, that there's millions of data points that an LLM is trained upon. What is the impact of some of the data that I am producing? Maybe like one data point that I'm producing, what is the impact of that data point in the overall model performance? So you might be surprised to know, but this is something that recently came out. So according to the very new algorithms that are being used to fine tune these LLM models, if you expose a gap in the model's knowledge from just one data point itself on that gap, the model will be able to close that gap from 50 to 60%. Of course, to fill it completely, you need exponentially more amount of data on that gap. But just from one data point, you are essentially pushing the model's capabilities forward by 50 to 60%. So now that is why we are now requiring data that is expert driven. Failing the models right now is not at all an easy task. You need to test the models on expert level, domain specific questions, domain specific prompts, And when the model is not able to give the correct answer, you provide what the correct answer should have been and you provide a feedback to the model. Now, this is where your expertise comes in when you provide the model with what the correct answer should have been on that expert level prompt that you have asked the model. Next up, let us look into another one of those terms that are flown around a lot in different projects, which is multi-turn versus single turn. Now, this is really easy to understand. A single turn is when you ask a prompt or when you ask the question to the model and you get a response from the model. This entire piece of conversation that you had with the model is called a single turn conversation. Now, if you continue this conversation with the model and then you ask a subsequent prompt to the model, now that then becomes multi-turn conversation. In this case, it is two-turn conversation. Now, in a coding context, please remember that the second turn or the subsequent turns that you're asking the model should be somewhat relevant to the first turn itself. It should not be completely different. For example, in the first turn, if you're asking the model to create a website or to create a particular application, in the second turn, you can ask the model to maybe add new features to the website, to maybe document the code or anything else, but that should be relevant to the first turn itself. If you ask the model to create a completely different application altogether, that is not advisable. That does not count as multi-turn. You're basically asking a new question to the model itself. Next up, let us look at this one really fascinating dataset that Scale has produced, which is called Humanities Last Exam. So if you go to Scale's website, this is the dataset called Humanities Last Exam. It consists of 3,000 of the most complex questions that humanity has, and we're testing the models if they can answer these questions correctly or not. So just to show you how well this dataset is curated, this is the performance of some of the super advanced LLM models across, some of the very commonly available benchmarks, which is your GPQA benchmark, your math benchmark, your MMLU benchmark. And all of these models, if you see, they're performing decently good. Some of them have even reaching accuracy scores of over 90%. And these models on the HLE dataset or Humanities Last Exam dataset, they're not even able to cross 15% accuracy threshold. This exposes that there is a huge gap that we still need to fill in order to make sure that these models become more and more advanced and more capable of answering the toughest questions that humanity has to ask. Very interestingly, if any of these models are able to perform really well on this particular benchmark, it would mean that humanity will lose the capability of asking tougher questions to the model. And this is the Humanities Last Exam. You can explore around a lot. You can see what types of different questions are there. And these are the results for some of the latest models that the HLE dataset has been tested on. And the highest accuracy we have gotten so far is by the O3 mini model, and still it does not cross the 15% threshold mark. Coming back to the topic, in today's video, we have discussed the different types of data that we produce, including SFTs, RLHF, and evals. What is the core difference between these types of data? In the next video, we will discuss what is the workflow of an RLHF project. That is going to be really interesting. So stay tuned for that.